In this section, we will graph quadratic functions. So all of the other sections in Chapter 10 are about quadratic equations. So we can solve them by factoring, or using the quadratic formula, completing the square, using the square root method. So we're going to employ all of those methods that's going to come up while we are graphing these equations. Okay, so the graphs that we've dealt with before are usually graphs of lines. Because of the square here, these graphs will not be lines. The shape of the graph will be a parabola. So let's just see that in the basic function y equals x squared. If we plug in -3, -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So we get these points. Let's go ahead and plot them. So -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's -3, 9. Here's -2, 4. Here is -1, 1, 0, 0. And then 1, 1. Notice that, so this point right here, that's going to be the vertex of this parabola. It'll be the lowest point. And the y-axis will be our axis of symmetry. So notice that these 2 points here are symmetric about the center. And then if you plug in 2, you get 2, 4. Notice that these 2 points are symmetric about the center. They're at the same height, 2 units to the left, 2 units to the right, both at height 4. And then 3, 9 is right there. Again, notice the symmetry here. All right, if we connect these points by a nice smooth curve, what you get, the shape that we get is a parabola. Notice that this parabola, it opens up. It's this up U shape. This point right here, which is the minimum point on the parabola, is called the vertex. So the vertex is at 0, 0. Its x-intercept and the y-intercept are the same. It's just the origin here, okay? And it's symmetric through the vertical line x equals 0. So the y-axis here, which is the vertical line x equals 0, is the axis of symmetry. So let's go ahead and draw those things in. Here's my vertex. It's also in this case, it's the 1 x-intercept, and it's also the y-intercept. And this axis right here, x equals 0, is the axis of symmetry. Okay, so it turns out that any quadratic, any equation with an x squared in it, and then maybe an x to the first power and a constant coefficient, it's going to be this same shape. This shape is called a parabola. It might be stretched, moved around. The vertex might be in a different location, or it might be flipped, so it might be opening down instead of opening up. So here are some features of the parabola that you'll need to look for. First of all is the vertex. Okay, anytime that you draw a parabola, it'll either open up or it'll open down. If it opens up, then the vertex will be the minimum. If it opens down, the vertex will be the maximum point on the graph. And here's how you find the vertex. If the equation is in standard form, ax squared plus bx plus c, then you find the vertex by calculating x equals -b over 2a. That tells you what the x coordinate of the vertex is. And then, of course, you're going to plug that, whatever that number is, you plug it in to figure out what the y coordinate is. Now, on the other hand, if the equation is in what's called vertex form, a times x minus h squared plus k. So if you only have like one instance of x here, then the opposite of this number is the x-coordinate of the vertex. And then this number here is the y-coordinate of the vertex. So it's kind of nice if the equation's written in vertex form, then you can just look at the symbols and automatically tell what the vertex is. Some other features, a parabola is always symmetric about the vertical line through its vertex. So just like we saw up here, if you know where the vertex is, you draw that line. Then if you plot like 2 points on the right-hand side of that line, you can automatically plot the 2 symmetric points on the left-hand side of that line. It just makes drawing the graph kind of easier. Also, you find the y-intercept by plugging in x equals 0, solve for what y is. So that'll be a point of the form, 0, comma, some number. And then the x-intercepts we find by setting y equals 0 and solving for x. So here you'd have to solve a quadratic equation. So you might have 2 x-intercepts, something comma 0 and something else comma 0. Sometimes we'll have 2 x-intercepts, sometimes only 1, and other times we might have no x-intercepts at all if our solutions are like complex numbers. And it's like, well, there's no real number that'll show up on the graph. Okay, and lastly, we need to think about that leading coefficient A. That has something to do with the shape of our graph as well. So 2 things. First of all, if the leading coefficient, the x squared term, if it's negative, if the A value is negative, the parabola opens down. If it's positive, the parabola opens up. Also, that leading coefficient A tells you something about how wide or narrow the parabola is. So for example, the smaller the coefficient, you want to think of like, let me go back to this graph. That coefficient A is going to either stretch or compress the graph. So if the coefficient is a large number, say bigger than 1, it will stretch this graph, and when you stretch it, the graph will get skinnier. If the coefficient is like a half or some fraction less than 1, it'll compress this graph, and in compressing it, the image will get wider. So let's see this in this next example. Y equals 3 times x plus 1 squared minus 9, and y equals a half times x plus 1 squared minus 9. So something I want you to notice first, these 2 equations, they're both in vertex form. Notice that our vertex here is -1, comma -9. Same thing here, the vertex is -1, comma -9. They both have positive leading coefficient, so they will both open up. So opens up, opens up. Now, 3 is greater than a half. So you think that this equation, this one will be stretched, so this one will be more narrow. And the equation with leading coefficient a half, that's going to be compressed, so it'll be more wide. So this graph should be narrower than this graph. What I'd like to do is show you these graphs on the graphing calculator. So if we go into y equals, if you have a graphing calculator, you can also go on desmos.com, which is an online graphing calculator. Let's go ahead and input this equation. 3 times x plus 1 squared minus 9. I'm going to take a look at its graph. So it opens up. The vertex is down here at -1, comma -9. And let's see if we can compare that to 1/2 times x plus 1 squared minus 9. Again, what I'm expecting to see is still going to open up. The vertex will still be at -1, -9, but since this one, the leading coefficient is smaller than 3, I'm expecting it to be wider because it's compressed a little bit further down. Let's see what the graph looks like. Yeah. So there it is, 1/2 times x plus 1 squared minus 9. It still opens up, same vertex, but since it's been squished down, it's more wide. So the first graph is narrower than the second graph.